Okay, so for chapter 4, Newton's law of motion. Okay, so learning objective for this chapter are understand and define the concept of inertia and the three Newton's law of motion. Second, analyze the forces on an object and describe the forces in the form of free body diagram. And the last one, to apply Newton's law of motion to solve problems in dynamics. Okay, so this one, the content for this chapter are introduction, Newton's law, type of forces, and last one, application of Newton's law. Okay, as introduction, in our study of kinematics, we saw that if the acceleration, initial position and velocity of a body are known, then the future position and velocity of the moving body can be completely described. But one of the things left out in the discussion was the cause of the body's acceleration. If a piece of chalk is dropped, it is immediately accelerated downwards. The chalk falls because the earth exerts a force of gravity on the chalk, pulling it downwards the center of the earth. We will see that anytime there is an acceleration, there is always a force present to cause that acceleration. In fact, it is Newton's law of motion that describes what happens to a body when forces acting on it. That branch of mechanics concerned with the forces that change the motion of bodies is called dynamics. This chapter will discuss in details all the three Newton's law of motion and the application of the Newton's law to solve problems in motion with constant velocity or acceleration, and to solve frictional force and static equilibrium under concurrent force problems. Okay, so this one just an introduction of Newton's law. Okay, so kita pergi detail lagi. Okay, first, Newton's law is a branch of mechanics. Mechanics is the study of motion of objects and the related concept of force and energy. Okay, so untuk mechanics, we have two branch which are kinematics and dynamics. Okay, untuk kinematics, the description of how object move. Maksudnya dia macam mana objek tu bergerak. Okay, dynamics deal with force and why object move as they do. Okay, untuk kinematik maknanya dia ceritakan macam mana objek tu bergerak. Okay, untuk dynamic dia ceritakan tekanan yang menyebabkan objek tu bergerak. Okay, why object move, sebab apa objek tu bergerak. Okay, so force is an agent that produce or tends to produce acceleration or cause a free body to undergo a change in speed, a change in direction, or a change in shape. Force cannot be seen, but we are able to see and feel the effects of force if it is acted on things. The SI unit for force is in Newton. N. Okay, so kita tahu dia ada satu force ataupun tekanan ke atas sesuatu objek. So dia akan merubah, dia mungkin akan merubah kelajuan, arah ataupun bentuk bila kita ada force kan, bila dia ada tekanan ke atas sesuatu objek. So unit untuk force adalah Newton, and then force tu kita tak boleh tengok tapi kita boleh rasa efek dia. Contohnya bila ada sesuatu tekanan kan ke atas badan kita, kita tak boleh tengok tapi kita boleh rasa. So unit dia adalah Newton. Okay, example of the effect due to forces. Okay, so yang ni contoh untuk effect hasil daripada forces. Okay, so first, forces can make things slow down or stop. Okay, a parachute can make an object slows down because of air resistance. Okay, contohnya macam payung terjun. So kalau payung terjun dia boleh jadikan slow kan. Dia boleh slow kalau ada tekanan daripada udara. Sebab tu kalau kita tengok bila dia turun daripada atas, so bila dia turun ke bawah, dia secara slow ataupun perlahan, sebab dia ada tekanan udara. Forces can make things change direction. For example, you can make a cricket ball change direction by hitting it with a bat. Okay, contoh satu lagi, dia boleh merubah arah. Okay, contohnya kalau kita ada bola kriket kan, kalau main bola kriket, bila dia lempar bola tu ke depan, and then kalau sampai pada kita boleh hit bola tu dan dia bergerak ke arah yang berlawanan. So change direction. And then forces can make things change its shape. Bentuk pun boleh berubah. When you squeeze a can, it will be compressed. Contohnya bila kita compresskan tin kan. Bila kita pegang rapatkan tin tu, dia akan mengecil, compress. And then next, forces can make things turn. You can use a spanner to tighten a nut. Okay, contoh satu lagi. Bila kita bagi tekanan pada spanner contohnya, so dia boleh ketatkan nut. So yang tu contoh-contoh untuk forces. Okay, what is Newton's first law of motion? Newton's first law of motion can be stated as a body at rest will remain at rest, and a body in motion at a constant velocity will continue in motion at that constant velocity unless acted on by some unbalanced external force. Okay, maksudnya untuk Newton's first law of motion, kalau body tu berada dalam keadaan rest, dia akan kekal rest ataupun kekal pegun. Then kalau body tu dalam keadaan bergerak dengan constant velocity, dia akan still dengan motion constant velocity. Okay, so Newton's first law of motion is also called the law of inertia. So kita panggil dia juga sebagai law of inertia. Inertia is the resistance of a body to a change in its motion. The mass of a body is a measure of its inertia, and the SI unit for mass is in kilogram kg. The greater the mass of a body, the greater is inertia. In other words, maksudnya mass tu berkadar langsung dengan inertia. Maksudnya kalau mass tu bertambah, mass tu makin besar, inertia makin besar. Okay, mass is a property of an object. Mass is not a weight. Weight is the force exerted on that object by gravity. If you go to the moon, whose gravitational acceleration is about 1/6 of the Earth's gravity, your weight is lesser as compared to at the Earth. However, the mass will remain the same whether at the moon or at the Earth. Okay, so yang ni dia cerita beza antara mass dengan weight. So ramai yang tertukar antara mass dengan weight. Okay, weight ni dia dipengaruhi oleh gravity, tapi mass dia sentiasa tetap. Maksudnya kat sini mass will remain the same whether at the moon or the Earth. Maknanya kalau mass ni ataupun jisim dia dekat bulan ataupun dekat bumi, jisim tu tak berubah sebab dia tak dipengaruhi oleh gravity. Tapi weight dia sentiasa berubah sebab dia dipengaruhi oleh gravity. So mungkin weight kita dekat bumi dengan dekat bulan tak sama. Okay, sebab dia ada tarikan gravity. So according to Newton's first law of motion, a stationary object will only move when there is external force acting on it. Maksudnya kalau objek tu yang rest, yang berada pegun, dia akan bergerak kalau ada tekanan external force ni, kalau ada external force. And then a moving object will only accelerates, decelerates or change its direction of motion if there is an external force on it. So maknanya kat sini based on Newton's first law, maknanya satu objek pegun dia boleh bergerak kalau dia ada external force. And then kalau objek yang sedang bergerak, okay, dia mungkin akan berubah kelajuan pecutan berubah, dan direction dia juga berubah kalau dia ada external force. Okay, so this one for Newton's first law of motion. Okay, kita tengok first bila a body at rest. Maknanya body tu dia tak bergerak. So, if forces act on a body and it does not move, the forces must balance. Hence, if a number of forces act on a body and it remains at rest, the resultant force in any direction must be zero. Okay, so maksudnya kat sini, katakan objek ni dia berada pegun ataupun tak bergerak. So, force dia, tekanan dia mesti balance ataupun resultant force dia mesti equals to zero. Okay, so kita tengok example 1. A body is at rest when subjected to the force shown in the diagram below. Find x and y. Dia kata body ni berada pada kedudukan rest. Maksudnya dia tak bergerak. Okay, so kalau dia tak bergerak, kita tengok total. Bila dia tak bergerak, maksudnya the sum of horizontal force must equals to 0. Maksudnya Fx, daya untuk Fx dia mesti sama dengan kosong. So dekat sini kita tengok jumlah Fx ke kanan 50 plus 10. And then ke kiri dia ada X. So 50 plus 10 minus X is equals to 0. Maksudnya kat sini awak boleh kira total dia equals to 0 ataupun force kanan dengan kiri mesti sama. So when you solve, it is equals to X equals to 60 Newton. So X ni dia mesti 60 Newton sebab dia mesti sama kiri dengan kanan ataupun jumlah ni mesti 0. So dia ada dua cara lah, awak boleh kira kiri kanan sama ataupun total kiri dengan kanan sama dengan kosong. Tapi kalau nak guna total ni, make sure direction dia kena ada positif ada negatif. Okay, so same with Fy. So the total vertical forces Fy is equals to 0. So 50 ni ke atas. Okay, so that's why this one we get 50. And then ke bawah minus 10 and minus y. So it is equals to 0. So your y is 40. So kalau kat sini pun kita boleh tengoklah tekanan bahagian atas which is 50 Newton. And then bawah ni pun mesti 50 Newton. So that's why y is 40. Because 40 plus 10 equals to 50. Okay, next untuk B. Okay, B pun sama the sum kat sini kalau awak tengok diagram, this one 70, so that's why y is equals to 60. And then x, kalau 60 plus 20, so x must equals to 80. Okay, so this one for B. Okay, 60 plus, okay sorry 60 plus 10 Okay, this one ada silap sikit dekat rajah dia 60 dengan 20. Tapi dekat solution dia kat sini 60 dengan 10. So you all boleh tukar kat sini lah. 10 ni jadikan dia 20. So x is equals to 80 Newton. Okay, next a body in motion. Okay, tadi dia tak ada pergerakan. So kita just focus on force. Okay, if a body in motion, a body can only change its velocity when it is increase its speed, slow down the speed, or change its direction if a resultant force acts upon it. Thus, if a body is moving with constant velocity, the resultant force must be 0. Okay, kita tengok kat sini. Okay, cuba tengok example ni. Dia ada velocity which is 5 ms negative 1. Okay, a body move horizontally at a constant velocity 5 ms negative 1 subject to the forces shown. Find P and S. Okay, so how we solve this one? Kalau dia ada pergerakan. Okay, untuk Fy, means okay Fy untuk vertical. Okay, S dia ke atas, so S minus 2000. Okay, minus 2000 plus S. Sebab kat sini ke atas kan. S kalau awak tengok kat sini okay, nilai S. Okay, this one kan dia ada positif S, positif S. So that's why S. Okay, then kat sini S 2000. So S 2000 di ke bawah. Dia kadang-kadang dia buat dekat atas ni rajah kan. Kadang dia letak dekat atas S dengan S. Kadang dia letak pada sama tempat yang sama. Cuma awak kena make sure tengok pada direction arrow ni. Okay, so S equals to 1000. And then horizontal velocity untuk yang ni okay, 3000. Okay, P ke kanan. So P and then ke kiri 300. So minus 300. So your P is equals to 300 Newton. So this one untuk A. Okay. So kat sini. Okay. Kalau awak tengok balik dekat sini. Okay. A body can only change its velocity when it increase its speed, slow down the speed or change its direction. Thus, if a body moving with constant velocity, the resultant force must be zero. Sebab apa kat sini dia tak ada perubahan pada velocity. So, velocity dia tetap 5. So, bila velocity dia 5, maknanya dia tak perlu consider pada kelajuan. Sebab dia tak berubah. So, dia tak ada acceleration. Maksudnya dia tak ada pecutan. So, awak boleh kira just untuk force. Okey, sama juga dengan B. S 200 dengan P. So, samalah kat sini S dengan S. And then minus 3000. Okay, so you get the value of S. And then horizontal velocity kat sini P minus 200. So, P equals to 200. Okay, so this one untuk solution B. Maksudnya S ni kan dia ada dua S kan. S. So 2S equals to 3000. So S equals to 1500. Ni sama sebab apa ni dia just constant velocity. So 5ms. So dia tak effect pada problem kita untuk velocity. Okay. Next is Newton's second law of motion. So for Newton's second law of motion, the rate of change of momentum of a body is directly proportional to the resultant force on it and is in the same direction as the resultant force. Newton's second law is represented by the expression F d dt mv or F equals to ma. So yang ni formula untuk Newton's second law of motion. Maksudnya dia berkait dengan acceleration. The second law of motion is consistent with the first law. From the second law, if there is no external force, then F equals to 0 since A equals to 0. When acceleration is 0, then either V equals to 0 is the object at stationary or at rest, or V equals to constant where the object moves with constant velocity. Okay, so case ni untuk Newton's second law. Okay, case bila ada acceleration. So kat sini if there is no external force, then F equals to 0. Maknanya kalau tak ada force, maknanya F dia akan sama dengan 0. Then A pun akan sama dengan 0. Okay, so kita tengok pada example. Okay, find the acceleration if a body of mass 8 kg is acted upon by the force of 10 Newton. Okay, yang ni pun dia silap ni 10 Newton bukan N10. Okay, so kita akan guna formula F equals to MA. So force dia bagi tahu kat sini is 10 Newton. So F kita ganti dengan 10 and then M is mass. Mass is 8 kg. So we now want to find A. So when you solve 10 divided by 8 equals to 1.25 ms negative 2. So you get the value of acceleration. So untuk second law of Newton's second law, you just use formula F equals to MA. Okay, same with B. Okay, B kat sini ni silap juga 10. Dia sepatutnya F equals to kat sini you all ubahlah sikit. Kat sini 15 kan. So this one is 15 Newton and then M is 5. Kat sini pun silap ni. Rajah dia silap. So kat sini you all boleh gantikan F equals to 15 and M equals to 5. So you get the value of A which is 3. Dia typing error sikit dekat rajah tu. Okay, then yang ni pun sama. Okay, this one dia bagi untuk example 4, dia bagi dekat sini A, the value of A which is 10. Okay, then the value of M. Okay, M jisim kat sini 200 gram. So make sure you change to standard unit which is kg. So kena tukar dalam unit kg. Okay, kena tukar pada unit kg. So kat sini that's why kita bahagi dengan 1000 kan. Sebab 200 gram equals to 0.2 kg because we divide by 1000. So ingat kena guna dalam standard unit. Okay, then a body of mass. Okay, this one kena, okay, untuk F, okay, there is no vertical motion. Kat sini, a body of mass 2 kg, okay, subject to force as shown in the diagram accelerates uniformly in the direction indicated. Find the acceleration. Okay, bila nak cari acceleration, first, untuk vertical, maknanya vertical ni bergerak ke atas dengan bawah. So, kita jumlahkan force dia, P dia ke atas, so that's why P plus negative 20, sebab yang ni 20 ke bawah. So jumlah untuk vertical motion adalah 20 P tolak 20 equals to 0. So that's why P equals to 20 Newton. So awak akan dapat P equals to 20. Okay, and then untuk horizontally, okay, kat sini dia beza sikit dengan sebelum ni. Kalau sebelum ni kita assume that fx is equals to 0 sebab dia cuma ada v kan. Tapi kat sini kita nak kira untuk acceleration, dia ada pecutan. So pecutan kita akan ambil formula f equals to ma, not f equals to 0. Yang ni kita ambil f equals to 0 because vertical motion. Dia bergerak ke atas bawah. So bila atas bawah dia tak ada pecutan. Pecutan cuma kanan dengan kiri. So this one kita ambil 10. Okay, 10 yang ni. Okay, positif 10. And then plus negative 4 sebab dia arah berbeza. Equals to MA. M is 2 kg darab dengan A, acceleration. So we want to find A, which is 3 ms negative 2. So make sure kena check betul-betul horizontally dengan vertical. So tengok dia bergerak ke atas bawah ataupun kiri kanan. Okay, then last one is Newton's third law of motion. Okay, Newton's third law of motion can be stated as every action has a reaction which is of the same magnitude but opposite in direction. Any time of force exerted of an object, that force is caused by another object. In other words, Newton's third law involve two different bodies. Okay, so kalau nak lebih faham, contohnya kat sini, force of ceiling on man, force of man on ceiling. Maknanya force tu ada untuk dua keadaan. Maknanya kalau contohnya apa ni, lelaki ni, man ni, dia ada force, and then ceiling ni pun dia force, lelaki ni dia ada force ke atas ceiling, and then ceiling pun dia ada force ke atas man ni. Maknanya dua-dua. So that's why kat sini dia kata that force is caused by any time of force exerted of an object. That force is caused by another object. Okay, contoh satu lagi yang ni, dia tolak dinding. So force of wall on hands and then force of hands on wall. Dua-dua ada force. So force always occurs in pairs. Force ni dia selalu ada dalam bentuk pasangan. For every action force, there is an equal and opposite reaction force. If two objects interact, the force F1 exerted on object 1 by object 1 is equal in magnitude and opposite direction to the force F2 exerted on object 2 by object 1. In other words, F1 equals to negative F2. So untuk Newton's third law, kita guna formula F1 equals to negative F2. Dia berpasangan tetapi direction yang berbeza. Dia opposite direction. Okay, so this one is contoh yang ni lah, objek 1 dia tolak objek 2, objek 2 tolak objek 1. So F1 equals to negative F2. Ataupun yang ni, action dengan reaction. This one also reaction and action. Okay, so this one for Newton's third law. So kita ada 3 untuk Newton's third law, F1 equals to negative F2. Untuk Newton's second law, F equals to ma, and then kita ada satu lagi Newton's first law. Okay, Newton's first law yang biasalah, maknanya jumlah force kan, kita based on jumlah force. Okay. So this one is Newton's first law of motion.